Now we start the next question in exercise 1.1, which is question number 3. This question is differentiate with respect to x, and the first example in which y is equals to x square plus 4x plus 1 whole raised to the power 3 plus x cube minus 5x minus 2 whole raised to the power 4. The given function already is in the form of u plus v, and we know that derivative of u plus v is du by dx plus dv by dx. After applying this rule, we can write the derivative of y with respect to x is dy by dx is equals to derivative of x square plus 4x plus 1 bracket cube plus again the derivative of ex cube minus 5x minus 2 whole raised to the power 4. This function is in the form of f of x whole raised to the power n, and we know that the derivative of f of x whole raised to the power n is n into f of x raised to the power n minus 1 into again the derivative of f of x. If we apply this rule, we can write here 3 into x square plus 4x plus 1 into again the derivative of x square plus 4x plus 1 plus the derivative of x cube minus 5x minus 2 raised to the power 4 is 4 into x cube minus 5x minus 2 whole raised to the power 4 minus 1 is 3 into again the derivative of x cube minus 5x minus 2. Now we can write it 3 into x square plus 4x plus 1 whole raised to the power 2. The derivative of x square is 2x plus 4 is constant and derivative of x is 1, and the derivative of 1, which is constant function, is 0, plus 4 into x cube minus 5x minus 2 whole raised to the power 3. The derivative of x cube is 3x square minus 5 into the derivative of x is 1 minus the derivative of 2, which is constant function, is 0. After that, we can write 3 into x square plus 4x plus 1 raised to the power 2 into 2x plus 4 plus 4 into x cube minus 5x minus 2 whole raised to the power 3 into 3x square minus 5, which is a required derivative of y dy upon dx. After that, the next example is y is equals to 1 plus 4x raised to the power 5 into 3 plus x minus x square whole raised to the power 8. Both the terms are in multiple form. If we consider first term is u and second term is v, then we can apply the derivative of u into v. And we know that the derivative of u into v is u into dv upon dx plus v into du upon dx. By applying this rule, we can write it differentiate a given function with respect to x. The derivative of y is dy by dx. First function 1 plus 4x raised to the power 5 into derivative of 3 plus x minus x square whole raised to the power 8. Again, plus means second term 3 plus x minus x square whole raised to the power 8 into derivative of u means derivative of first term, which is 1 plus 4x whole raised to the power 5. After differentiating, we can write it 1 plus 4x as it is. Derivative of x raised to the power n is n into x raised to the power n minus 1. Hence here we can write 8 into 3 plus x minus x square whole raised to the power 8 minus 1 is 7, and we can take again a derivative of 3 plus x minus x square. After that, second term plus 3 plus x minus x square as it is whole raised to the power 8. Here the derivative of 1 plus 4x raised to the power 5 is 5 into 1 plus 4x whole raised to the power 5 minus 1 is 4, and we take again derivative of considerable function which is 1 plus 4x is in bracket. After that 1 plus 4x whole raised to the power 5, we can write 8 here into 3 plus x minus x square whole raised to the power 7 into 1 minus 2x plus 3 plus x minus x square whole raised to the power 8. This 5 we can write here into 1 plus 4x whole raised to the power 4 into 0 plus 4. 0 plus 4 is 4. 4 into 1 is 4 into 4. Hence we can write it 8 into 1 minus 2x into 1 plus 4x whole raised to the power 5 into 3 plus x minus x square whole raised to the power 7 plus 5 into 4 is 20 into 1 plus 4x into 3 plus x minus x square, 3 plus x minus x square, which is the required derivative of y, dy upon dx. Next, example number 3 is y is equals to x upon under root of 7 minus 3x. If we directly differentiate with respect to x, the derivative of y is dy by dx. We can write it d upon dx, x upon under root of 7 minus 3x. The given function is in the form of u upon v, and we know that the derivative of u upon v is denominator v into du by dx minus numerator u into dv upon dx upon square of denominator means v square. By applying this rule, we can write it denominator of v means under root of 7 minus 3x into derivative of numerator means x. Again the sign minus, u means numerator x into derivative of denominator means under root of 7 minus 3x, and the square of denominator means under root of 7 minus 3x whole bracket square. After that we can write it under root of 7 minus 3x into derivative of x is 1 minus x into derivative of under root x is 1 upon 2 root x. Here x replaced by 7 minus 3x, hence we can take again a derivative of 7 minus 3x upon square and square root is cancelled, hence we can write it 7 minus 3x. Under root of 7 minus 3x into 1 under root of 7 minus 3x minus x into 1 is x upon 2 under root of 7 minus 3x into the derivative of 7 which is constant function, and the derivative of minus 3x, minus 3 is constant and the derivative of x is 1 upon 7 minus 3x as it is. After that minus 3 into minus, we can write it under root of 7 minus 3x minus minus plus 3x upon 2 under root of 7 minus 3x upon 7 minus 3x. We can write also it after solving is equals to under root of, if we take the cross product of these both, then 2 into under root of 7 minus 3x into under root of 7 minus 3x is 2 into 7 minus 3x plus 3x into 1 is 3x upon in denominator 2 under root of 7 minus 3x into 7 minus 3x. 2 into 7 is 14 minus 2 into 3 is 6x plus 3x upon 2 into 7 minus 3x, under root of 7 minus 3x also can write in 1 by 2 is form, into 7 minus 3x is the power here, power of the 7 minus 3x is 1. 14 as it is, minus 6x plus 3x minus 3x upon 2 into, if we use the rules of entices, m raised to the power n plus m raised to the power p is equals to m raised to the power n plus p. If base is equal, then we can take sum of the power. Hence we can write it 7 minus 3x raised to the power 1 by 2 plus 1. Hence we can write again 14 minus 3x upon 2 into 7 minus 3x whole raised to the power 3 by 2, which is a required derivative of y dy upon dx. Next example, example number 4 is y is equals to x cube minus 5 whole raised to the power 5 upon x cube plus 3 whole raised to the power 3. If we differentiate given function, we can write the derivative of y is dy by dx, and we take again derivative of whole functions. We know that the given functions is in the form of quotient form, and in the quotient form we can apply here the derivative of u upon v. The derivative of u upon v is v into du by dx minus u into dv upon dx upon whole square. It means that first function into derivative of second function minus first function into derivative of second function upon v square. Hence we can write it second function x square plus 3 x cube plus 3 whole raised to the power 3 into derivative of x cube minus 5 whole raised to the power 5 minus x cube minus 5 whole raised to the power 5 into derivative of x cube plus 3 whole raised to the power 3 upon x cube plus 3 whole raised to the power 3 whole bracket square v square. Now we can write it x cube plus 3 whole bracket cube. If we apply the derivative of x raised to the power n, we can write 5 into x cube minus 5 whole raised to the power 4 into again a derivative of x cube minus 5 minus x cube minus 5 whole raised to the power 5 as it is. If we apply the derivative of f of x raised to the power n, then we can write it 3 into x cube plus 3 whole raised to the power 2 into again the derivative of x cube plus 3 upon x cube plus 3 whole raised to the power 3 into 2 is 6. After that, x cube plus 3 whole raised to the power 3 as it is into 5 into x cube minus 5 whole raised to the power 4 as it is. The derivative of x cube is 3x square minus derivative of 5 is 0 minus x cube minus 5 whole raised to the power 5 as it is into 3 into x cube plus 3 whole raised to the power 2 into again derivative of x cube is 3x square plus the derivative of constant function is 0 upon x cube plus 3 whole raised to the power 6. After that, we can write x cube plus 3 bracket cube into 5 to 3 15x square x cube minus 5 whole raised to the power 4 minus x cube minus 5 whole raised to the power 5 as it is into 3 into 3 9x square into x cube plus 3 whole raised to the power 2 upon x cube plus 3 whole raised to the power 6. After that, we can take x square x plus 3 whole bracket cube, x cube plus 3 4 raised to the power 2, x cube minus 5 whole raised to the power 5, x cube minus 5 whole raised to the power 4. We can take 15 x square 9x square, 3x square is common, x cube plus 3 whole bracket cube, x cube plus 3 whole bracket square, x cube plus 3 whole raised to the power 2, x cube minus 5 whole raised to the power 4, x cube minus 5 whole raised to the power 5, x cube minus 5 whole raised to the power 4 common. After that, remaining terms we can write here. 5 into 3, 15 is 5. X cube plus 3 is cube. We take a common x cube plus 3 square, then we can write 5 into x cube plus 3 minus, here we take 3 common, 3 into 3, 9, 3. X cube minus 5 whole raised to the power 4 is common, hence we can write x cube minus 5 upon x cube plus 3 whole raised to the power 6. After that, 3x square into x cube plus 3 whole bracket square into x cube minus 5 whole raised to the power 4 into 5 into x cube, 5x cube plus 5 into 3, 15 minus 3 into x cube, 3x cube minus minus plus 15 upon in denominator x cube plus 3 whole raised to the power 6. After that, 3x square, x cube plus 3 whole raised bracket square into x cube minus 5 whole raised to the power 4. 5x cube minus 3x cube is 2x cube. 15 plus 15 is 30 upon x cube plus 3 whole raised to the power 6. If we take 2 common in this bracket, then we can write 2 into 3, 6 into x square into x cube plus 3 whole bracket square into x cube minus 5 whole raised to the power 4 into x cube minus 15 upon x cube plus 3 whole raised to the power 6, which is a required derivative of y, dy upon dx. Sorry, x cube plus 15. Next one. Find number y is equals to 1 plus sin square x bracket square into 1 plus cos square x bracket cube. If we differentiate given function with respect to x, then we can write the derivative of y is dy by dx. Again, here both terms are in multiple form, then we can apply here the derivative of u into v. Derivative of u into v is du into dv by dx plus v into du by dx. Hence we can write it 1 plus sin square x whole bracket square into derivative of 1 plus cos square x whole bracket cube plus 1 plus cos square x whole bracket cube into derivative of 1 plus sin square x. After differentiating 1 plus sin square x whole bracket square as it is, the derivative of 1 plus cos square x whole raised to the power 3 means x raised to the power n is 3 into 1 plus cos square x raised to the power 3 minus 1 is 2 into again the derivative of 1  1 plus cos square x. 1 plus cos square x whole bracket square as it is. The derivative of 1 plus cos square x whole raised to the power 3 means x raised to the power n is 3 into 1 plus cos square x raised to the power 3 minus 1 is 2 into again the derivative of 1 plus cos square x. plus 1 plus cos square x whole bracket cube as it is into 2 into 1 plus sin square x raised to the power 2 minus 1 is 2 into again a derivative of 1 plus sin square x. After that 1 plus sin square x bracket square as it is into 3 into 1 plus cos square x whole bracket square into derivative of 1 is 0 plus derivative of cos square x is 2 cos x into again derivative of cos x is minus sin x. Hence the derivative of cos square x is minus 2 sin x into cos x plus 1 plus cos square x whole raised to the power 3 as it is into 2 into 1 plus sin square x as it is. Here the derivative of 1 is 0 plus derivative of sin square x is 2 sin x into again derivative of sin x is cos x, it means that 2 sin x into cos x. Again we can write 1 plus sin square x bracket square into 3 1 plus cos square x whole bracket square into minus 2 sin x is into cos x is sin 2x plus 1 plus cos square x bracket cube as it is into 2 into 1 plus sin square x into 2 sin x into cos x is sin 2x. After that 3 into minus 3 sin 2x into 1 plus sin square x bracket square into 1 plus cos square x bracket square plus 1 plus cos square x bracket cube into 2 into 2 sin 2x into 1 plus cos square x bracket cube into 1 plus sin square x. If we take sin 2x common, 1 plus sin square x, 1 plus cos square x, then we can write sin 2x into 1 plus only sin square x into 1 plus cos square x, then we can write it minus 3 1 into 1 plus sin square x plus 2 into 1 plus cos square x. After that we can write sin 2x into 1 plus sin square x into 1 plus cos square x into minus 3 into 1 minus 3 sin square x plus 2 cos square x. Hence we can write sin 2x into 1 plus sin square x 1 plus cos square x minus 3 plus 2 minus 1, hence 2 cos square x minus 3 sin square x minus 3 plus 1 minus 1, which is a required derivative of y dy upon dx. It is a 1 plus cos square x whole bracket square. We can also write it again, dy by dx is equals to sin 2x as it is, 1 plus sin square as it is, 1 plus cos square x whole bracket square as it is. We can write 2 cos square x, 2 into cos square x converted into 1 minus sin square x. The value of 1 minus sin square x is cos square x minus 3 sin square x minus 1. After that we can write sin 2x, 1 plus sin square x, 1 plus cos square x whole bracket square into 2 into 1, 2 minus 2 sin square x minus 3 sin square x minus 1. After that sin 2x as it is, 1 plus sin square x, 1 plus cos square x into 2 minus 1 is 1, minus 2 minus 3 is minus 5 sin square x, which is the required derivative of y divided upon dx. This is a final terms of dy by dx. Next example number 6 is y is equals to under root of cos x plus under root of cos of root x. If we differentiate a given function, we can apply directly the derivative of under root x. Derivative of under root cos x plus derivative of under root of cos of root x. The derivative of root x is 1 upon 2 root x. Hence we can write upon 2 root of cos x into again the derivative of cos x plus the derivative of root x is again 1 upon 2 under root of cos x into again a derivative of cos of root x. Here we will apply the derivative of under root of fx is 1 upon 2 root fx into again derivative of fx. Similarly we can apply here. The derivative of cos x is minus sin x, hence we can write minus sin x upon 2 under root of cos x plus the derivative of cos root x is minus sin root x upon 2 under root of cos root x into again a derivative of root x minus sin x upon 2 under root of cos x as it is minus sin of root x upon 2 under root of cos of root x into again derivative of root x is 1 upon 2 root x. After that, if we take 1 by 2 common from here on minus sin x upon 2 under root of cos x minus sin root x into 1 sin root x upon 2 into 2 4 under root x as it is into under root of cos of root x, which is the required derivative of y dy upon dx. Example number 8, y is equals to log of sec 3x plus tan 3x. We know that the derivative of log of fx is equals to 1 upon fx into again a derivative of fx. By applying this rule, we can differentiate with respect to x. The derivative of y is dy by dx. Again we can take the derivative of log of sec 3x plus tan 3x. The derivative of log x is 1 by x, derivative of log of f of x is 1 upon fx, hence we can write it 1 upon sec 3x plus tan 3x into again a derivative of sec 3x plus tan 3x. Now we can take a separate derivative of sec 3x and a separate derivative of tan 3x, hence we can write derivative of sec 3x plus derivative of tan 3x upon sec 3x plus tan 3x. Derivative of sec x is sec x into tan x. Hence we can write the derivative of sec 3x is sec 3x into tan 3x into again a derivative of 3x plus derivative of tan 3x is sec square 3x into again a derivative of 3x upon sec 3x plus tan 3x as it is. Here the derivative of 3x is 3. 3 into sec 3x into tan 3x plus derivative of 3x is again 3. 3 into sec square 3x upon sec 3x plus tan 3x. If we take 3 sec 3x common from both terms, then we can write say 3 sec 3x into remaining here tan 3x plus sec 3x is common, hence we can write again sec 3x upon sec 3x. We can write also it tan 3x plus sec 3x. Both terms of numerator and denominator are common, hence we can write 3 sec 3x, which is the required derivative of the given functions. In this example, we consider x degree is a composite function. After differentiating with respect to x, dy upon dx, and we take the derivative of 1 plus sin x degree upon 1 minus sin x degree. Given function is in the quotient form. If we consider that the numerator is u and denominator is v, then we apply derivative of u upon v, and the derivative of u upon v is v into du by dx minus u into dv upon dx whole bracket square. After differentiating 1 minus sin x degree as it is into we take a derivative of 1 plus sin x degree minus 1 plus sin x degree into a derivative of 1 minus cos sin x degree upon 1 minus sin x degree whole bracket square. 1 minus sin x degree as it is, the derivative of 1 is 0 and the derivative of sin x is cos x. X degree is composite function, hence we can write the derivative of sin x degree is cos x degree into again a derivative of x degree minus 1 plus sin x degree as it is, derivative of 1 is 0 minus the derivative of sin x degree is again cos of x degree into again a derivative of x degree upon 1 minus sin x degree whole bracket square. Here we take the derivative of x degree common from both terms, then we can write it 0 plus cos x degree is cos of x degree into 1 minus sin x degree minus 1 plus sin x degree into minus plus cos of x degree into derivative of x degree upon 1 minus sin x degree whole bracket square. Again here we take cos of x degree common from both terms. We can write cos of x degree into 1 minus sin x degree plus 1 plus sin x degree into derivative of, we can't take the derivative of x degree, hence we convert this degree into radian. If we want to convert the terms of degree in radian, then we multiply this term pi upon 180. Hence x degree convert into pi x upon 180 radian. Then we can write here pi x upon 180 upon 1 minus sine of x degree whole bracket square. Here minus sine x degree plus sine x degree cancel. 1 plus 1 is 2. Hence we can write 2 cos of x degree, 2 cos of x degree into pi upon 180 is again constant, and the derivative of x is 1 upon 1 minus sine of x degree whole bracket square. After that 2 into 1 is 2 cos of x degree upon 1 minus sine of x degree whole bracket square, which is a required derivative of the given function dy upon dx, into pi upon 180. That is 2 cancel, 180 half 90, means pi of cos x degree upon 1 minus sine of x degree whole bracket square. This is the final answer of given differentiable function. Example number 9 is y is equals to cot of log of x by 2 minus log of cot of x by 2. After differentiate with respect to x, we can take a separate derivative of both function. Derivative of cot of log x upon 2 minus derivative of log of cot x upon 2. We know that the derivative of cot is minus cos x. Hence, we can write the derivative of cot of log of x by 2 is minus cos x square log of x upon 2, and we take again the derivative of log of x upon 2 minus derivative of log x is 1 by x. Hence we can write the derivative of log of cot of x by 2 is 1 upon cot of x upon 2, and we take the again derivative of cot of x upon 2. We can write this minus cos x square log of x upon 2 into 1 by 2 is constant into derivative of log x is 1 upon x minus, we can write this 2 in numerator upon cot x. 1 by 2 is constant function, and the derivative of cot x is minus cos x square x. After that minus 1 upon 2 into x is 2x cos x square log x upon 2 minus 2 to cancel, 1 upon cot is tan x into cos x square x, and the minus minus is plus, which is a required derivative of y dy upon dx. This example number 10 is y is equals to e raised to the power 2x minus e to the power minus 2x upon e to the power 2x plus e to the power minus 2x. First we simplify this example. After simplifying, we can write it e to the power 2x. If the power of e to the power minus 2x is negative, then we can write it v1 upon e to the power 2x upon e to the power 2x plus 1 upon e to the power again 2x. If we take a cross product of both numerator and denominator, then we can write e to the power 2x into e to the power 2x is e to the power 4x minus 1 into 1 is 1 upon e to the power 2x upon e to the power 2x into e to the power 2x e to the power 4x plus 1 upon e to the power 2x. These both denominator are cancelled. Hence we can write it e to the power 4x minus 1 upon e to the power 4x plus 1. After that, we can differentiate a given function with respect to x, then we can write the derivative of y dy by dx is equals to derivative of e to the power 4x minus 1 upon e to the power 4x plus 1. If we apply here the derivative of u upon v, then we can write dy upon dx is equals to denominator e to the power 4x plus 1 into derivative of e to the power 4x minus 1 minus e to the power 4x minus 1 into derivative of e to the power 4x plus 1 upon e to the power 4x plus 1 whole bracket square is equals to e to the power 4x plus 1 as it is. We can write the derivative of e to the power 4x is 4x into e to the power 4x, or the derivative of e to the power 4x is e to the power 4x into again derivative of 4x minus e to the power 4x minus 1 into derivative of e to the power 4x is 4x e to the power 4x, and the derivative of plus 1 is 0 upon denominator e to the power 4x plus 1 whole bracket square. Derivative of 4x is again 4 e to the power 4x e to the power 4x plus 1 into e to the power 4x, and the derivative of 4x is 4 into e to the power 4x minus 4 into e to the power 4x into e to the power 4x minus 1 upon e to the power 4x plus 1 whole bracket square. If we take 4 into e to the power 4x common both terms, then we can write e to the power 4x plus 1 minus e to the power 4x minus plus 1 upon e to the power 4x plus 1 whole bracket square. Here plus e to the power 4x minus e to the power 4x cancel. 1 plus 1 2, 2 into 4 8. Hence we can write 8 e to the power 4x upon e to the power 4x plus 1 whole bracket square, which is a required derivative of the given function, which is e to the power 2x minus e to the power minus 2x upon e to the power 2x plus e to the power minus 2x. Next example number 11, y is equals to e to the power root x plus 1 upon e to the power root x minus 1. If we differentiate the given function with respect to x, then the derivative of y is dy by dx into again a derivative of e to the power root x plus 1 upon e to the power root x minus 1. The given function is in the quotient form. Hence we can apply here the derivative of u upon v. And we know that the derivative of u upon v is v into du upon dx minus u into dv upon dx upon v square. Similarly, we can write here e to the power root x minus 1 into derivative of e to the power root x plus 1 minus e to the power root x plus 1 into derivative of e to the power root x minus 1 upon denominator e to the power root x minus 1 whole bracket square. E to the power root x minus 1 as it is, derivative of e to the power root x is e to the power root x into again the derivative of root x, and the derivative of plus 1 is 0 minus e to the power root x plus 1 into derivative of e to the power root x is e to the power root x as it is into again a derivative of root x, and the derivative of minus 1 is 0 upon e to the power root x minus 1 whole bracket square. Hence we can write it e to the power root x minus 1 as it is, e to the power root x as it is, and the derivative of root x is 1 upon 2 root x minus e to the power root x as it is plus 1 e to the power root x into derivative of root x is 1 upon 2 root x upon e to the power root x minus 1 whole bracket square. If we take e to the power root x upon 2 root x common both terms, we can write e to the power root x upon 2 root x into e to the power root x minus 1 minus e to the power root x minus plus minus 1 upon e to the power root x minus 1 whole bracket square. After that, we can write it e to the power root x in numerator plus e to the power root x minus e to the power root x cancel upon 2 root x into minus 2 upon e to the power root x minus 1 whole bracket square. 2 to cancel. Hence we can write it minus e to the power root x upon e to the power root x minus 1 whole bracket square, which is required derivative of given function dy upon